Right, so you're just getting into the world of microcontrollers, you know, the ESP32, the Arduino Uno, which we all know and love, or the Elegoo Uno, because who can afford Arduino these days? This also means that your social life is slowly fading away, but that's a story for another time. Today I have a fun, educational starter project that will use either one of these two microcontrollers. I'll show you how to adjust the code, it's really simple, and mainly an RFID reader. You can get these off like eBay or Amazon for like 2-3 quid, and it should come with, you know, some RFID tags, which I don't seem to have around me, but it did, I promise you. Sometimes it even comes with starter kits, which I think are the best way to get into Arduino. Just go on Amazon, search up Elegoo Uno R3 starter kit, and boom! You got amazing options there. Sometimes if you already bought the Arduino, it comes with a bunch of starter kits that doesn't include this, so it's cheaper. But you should always definitely have a couple of these on you, just because you can like make a project and like keep it permanently, like this project. We're gonna have an RFID reader under something, and then this little like RFID coin, which should come with this. And we're gonna just, you know, plop that into your snacks, and then whenever the snacks get removed from the platform, the RFID will go away from the reader, and then beep 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 beep. Anyway, this is what we're gonna actually go through. We have the what you will need category, of course. We have the assembly. Then we'll go through how to upload the code, final touches, and then a quick explanation of how the code works for all you super nerds out there. But that'll be afterwards. Oh, and if you actually watch to the end, there's a really nice short 1-minute movie of this product in action, which I think you guys really love. So this is what you're going to need. It's a super simple project in terms of equipment, so don't worry. All you'll need is your choice of microcontroller, so either the Arduino or the ESP32 is what we're showing today. An RFID reader, an RFID chip, which, as I said, should come in. I'm going to take these glasses off, they're making me feel weird. Which, as I said, should come in a bundle. You'll need a buzzer, you'll need a bunch of wires. Now, in terms of wires, it's going to depend if you have male to female connections, which look like this, or male to male. If you have male to male, which are just kind of like the average things, you'll also need a breadboard. But in this example, we'll be using male to female, just because, I don't know what that was, oh my god. And then lastly, we'll need something to put it in. You can literally use like a shoe box, you can use a regular box, you can, any box, anything. Or if you have like a specific place you want to put this in, then you can really like build it around the place. Like if you want to put it on a shelf, then you can build it around the shelf. I don't know, just use a box, alright? You get the point. Right, now this is how you assemble it. And boom, double cam, look at that. Anyway, the first thing we're gonna do is we're gonna wire up the RFID reader. This isn't necessary if you're using a breadboard, but as we're not, we're gonna have to wire it up. But when you are wiring, I'm just gonna untape it and show you. We're gonna basically wire up everything except the RQ. We will not be needing the RQ, so I don't have to add a wire to that one there. So then for the rest of them, we have SDA, which is gonna be like your chip select, so we're gonna have to define that. Next up, we have SCK, which is a little bit different. Then we have MOSI and MISO. All that means is MISO and MOSI, they stand for either master out, slave in, or master in, slave out. And then obviously we got ground, which is going to go to ground. We have reset, which will basically just reset the RFID, which is actually really important, and we will also have to define that in the code. And then lastly, we have 3.3 volts. Do not, and I repeat, I don't care what you're using, do not plug this into a 5 volt. All right, let me tape it up in a way where we can still see what the connections are. All right, next thing we're going to do is we're going to connect it to the microcontroller. Now, once again, you can either use the ESP32 or the Arduino, and it's really the same process. This right here is the circuit diagram for the ESP32, if you're wondering, but if you're using the Arduino, you got a whole video, isn't that a treat? Right, so the first one is going to be the SDA wire, which is going to go to the Arduino pin 10. Nice and simple beginning, am I right? Next up, we have SCK, which is going to be this little orange wire right here, and that's going to go straight to pin 11. Next up, we have the SCK wire, which is just the next one in line, and this is going to hook onto pin 13. That's 12, whoops. There you go, 13. Next up, we have the MOSI one, and this is going to go straight to pin 11. and then MISO is going to go to 12. Now, a really common mistake is for someone to mix up MOSI and MISO. So if it doesn't work, just double check that you have the MOSI and the MISO pins the right way around. It is really important. And now you're going to skip one. So you're going to skip over RQ and go straight to ground. And ground is going to simply go straight to ground. We're going to put it right there. Next up, we have the reset, and the reset is important. Sorry, I sound like a roadman. And we're also defining this in the code, so you can change it up if you're adding something else. But for my code, I did it as 9, just to kind of keep it in a nice numerical order. And they're all right next to each other, so it's really easy to like electrical tape it all together so it doesn't, you know, move like we did with the RFID reader. Lastly, you have 3.3 volts. Please don't plug it into 5 volts. I'm generally begging you, double check that before we plug it in, because it's bad. And there you go. Right, so what I was gonna say before that happened is we're first gonna look at how to upload the code. Now it's really simple. It's a quick Arduino IDE tutorial. This is what you will need. You'll need to download Arduino IDE. You can just go on Google or Microsoft Edge if you're weird like me, and just search up Arduino IDE, look for the actual Arduino website, click on that, just accept, choose your device, so Windows 10 or newer, so that's Windows 11 as well, 64-bit, and just press download, and then go through there. Copy and paste this code. The code is in the description, so you can go check it out. It's free, you just press it, and you'll go onto this thing here. But anyway, let's get into how to verify and upload the code. While coding, at least, you're going to want to press verify, and that's just going to check through everything you've written so far, just to make sure there's no syntax errors, which is where the code won't even run. So it just double checks it, sees that everything is good, you're done, and then at the end, when you're done writing the code, or in this case, when you just want to upload the code, you're going to press this little arrow here, says upload, and that's going to upload straight to the thing and verify at the same time. But you may be asking, okay, how do I, choose the Arduino Uno? How do I choose the ESP32? Let me show you. So what you're going to want to do is you're going to want to go to up here, press select other board and ports. And if you have an Arduino, nice and simple, you're just going to want to search up Arduino, I can't spell Uno, and select Arduino Uno. And then, so you select which board you have, which in this case is the Arduino Uno. Even though we're using the Elegoo Uno, not the Arduino version, it's okay, just select Arduino Uno, it still works. And then ports is just whatever USB port it's plugged into, press OK. Now, if you're using an ESP32, it's slightly different. I'll show you very quickly. You press Tools, you go down to Board, and you press Board Manager. Or you just press Control-Shift-B. And then filter your search, just write ESP32, wait a couple seconds, download both of these two. See, I need to update that, I'll do that later. Download both of these two, and then press this thing here to close out of that. Once they're downloaded, you're going to go back into select board and port. You're going to have to scroll down until you find ease. There you go. All the ESP32 should be downloaded by now. And whenever you buy the ESP32, because there's a lot of different versions, check the description, check maybe the reviews, check the name to see which one it is. If all else fails, like for example, I couldn't use this one, there's a little camera on there, it wasn't working with the dev kit, I just choose the ESP32 Rover kit, all versions. It works most of the time, alright? If your specific ESP32 has a different name, look for it. And so after you've chosen the board and port, then you want to upload. Once again, just press that little arrow and it will do its thing. I'll cancel now because I, just uploaded. And that's it. Now, let's actually put this in the box and then I'll show you how the code works and then the demonstration. All I did, right, boom, I cut up a little piece of cereal box and made a very small type of box thing here. I'm going to tape that bit down and then I'm going to have these two things kind of fold in so I can kind of open it up. Now before we start putting everything together, or at least before you start making your box fully, you need to think about how you're going to power the Arduino. So there's two ways to do it. First of all is just plug in a wire and then plug that into mains or a power bank or whatever. Second of all, at least with the Arduino, it's literally just a 9-volt battery and then this attachment here, which, yeah, this attachment should come with basically every kit that you buy. And then, yeah, this can just literally plug it straight in to there, and it's powering the entire Arduino. They have a very, very long battery life. And also, I'm just going to tell you that once you fight your friends steal your food and it starts beeping and it just doesn't stop, you can reset it by just pressing this little button here, and that will reset the actual Arduino, reset the code back from the start. So once again, you'll have 5 seconds to replace it, or you can just unplug it and plug it back in. That also works. So yeah, I'm going to be taping it down. You can hot glue it, you can try to super glue it, but I wouldn't recommend it. Maybe double-sided sticky tape as well. I'm just going to use electrical tape.
One eternity later.
We have the box. It's nice and simple. We have the little X there where the RFID reader is, so you don't, you know, put it somewhere else and it starts beeping. We have the buzzer. We cut a little hole out for it so it actually, you know, sounds. And then the other side, I didn't actually tape it down, so I can open it and, you know, unplug the battery, reset it, or hopefully I can open it. Jesus, there you go. So I can just kind of see the inside, I guess, and do everything I need to do, and then just close it up. Okay, now let's look at how the code actually works. It's quick and simple, don't even worry. So first of all, what's going to happen is we're going to include 2 libraries. These are the libraries, by the way. And what this is, it's basically pre-written code. Instead of writing, you know, hundreds of lines for like a task, you just have to write that, and then obviously put your variables in, and it's way, way simpler and quicker. Then we're defining all the different pins that we used, so the SS, the reset, and the buzzer. And then for the ESP32, you're just going to look at where the SDA pin from the RFID goes to the ESP. You're going to look at where the reset pin goes from the RFID to the ESP, and then where the buzzer goes. We're going to initiate 2 checks here. Basically, because these type of RFIDs are created to kind of scan a card and then that's it. It's not made to like constantly check if there's a card there. What happens is for 1 second it thinks it's there, 1 second it thinks it's not there, not there, not there, over and over again, even though you haven't moved the RFID whatsoever. So just to make it work better, what I've done is I've made it go through it twice. So if either check 1 or check 2 notices that there's a card there, then the tag is present. If either check 1 or check 2, if neither of them realizes there's a tag present, then the tag's missing and the buzzer goes off. Woo, woo, woo. But if you want to make the buzzer stop when you place the snack back onto the platform, which I wouldn't recommend because then they will just, you know, put it back down and then eat it from the bag while it's on there. But if you do, for some reason, want to do that, just remove these 2 slashes and that will uncomment it. In the setup, we're gonna initiate the actual serial begin at 9600 baud. Double check that's the same one here, 9600 baud, because if it's not, let's say if it was at 19200, it's gonna start spitting out gibberish. So if you ever look at the serial monitor and it's random gibberish, just make sure these 2 are the exact same. Once again, works perfectly. Then we're initiating the SPI bus. Once again, it's the data thing between the RFID and the Arduino. So if you're sending data either way, so from the Arduino to the RFID reader, which would be, you know, turn on, turn off, and then most importantly, data from the reader straight back to the Arduino, like, you know, the UID or the tag is present, you know, stuff like that. And then this is initiating the actual RFID reader. Then you're going to set the buzzer to be an output pin, which means that it will deliver a current to the pin that the buzzer is plugged into, instead of waiting to get current back if that's said input. Then we're going to delay for 5000 milliseconds, which is just 5 seconds. So you have 5 seconds to place the snack on the platform when you turn it on. And then in the loop, we're going to double check the card is present. We're gonna see that the card has a UID, which you can use in the future if you want to add a little feature where only one specific RFID chip will work, because you just have only their UID. And then yeah, if both of them are realized, you know, if there's a tag, then check 1 equals 1, otherwise check 1 equals 0. Same thing again, so then if at least one of them is a 1, it's present, as I said. And yeah, that right there is the entirety of the code. As I said, really simple, really nice. And now let's get to the demonstration.
Honey, I'm home.
Never call me honey ever again.
My joker, jeez.
This seems way too easy. Idiot.
Oi, get off my Maltesers!
Who the hell puts this much effort into protecting a half-eaten bag of sweets?